Good afternoon. My name is Anthony Slack, CEO of Elstar Dynamics. Today, I will talk to you about dynamic glass and the role that the display industry might play in its success. Elstar Dynamics is an established deep tech company based in Eindhoven in the Netherlands. We have developed a new type of dynamic glass based upon electrophoresis. The technology is both highly effective and very simple to produce using existing display manufacturing facilities. We call this technology ELM for electrophoretic light modulator. Building sector is the largest contributor to global carbon footprint, being responsible for almost 40% of global greenhouse gas emissions. Dynamic glass, on the other hand, is estimated to be capable of reducing energy used on building climate control by more than 20%. At the same time, there is a profound change taking place in the automotive industry with the shift towards EVs. Each of these megatrends is having a profound impact on global economies and those technologies that might be effectively used to reverse climate change. A number of alternative dynamic glass technologies already exist, ranging from electrochromic, guest host LCD, and SPD. However, each of these have limitations in terms of both performance and cost. When Elstar set out to develop an alternative technology, we aimed not only at providing a level of performance suitable for all applications, but also meeting a cost point at which the technology would be affordable and scalable. We believe we have the most versatile and adaptive smart glass technology on the market, any size, shape, or color. We have the widest dynamic range in the visible spectrum, from below 0.2% to above 70% transparency. That represents a 10 to 15 times better contrast ratio than existing technologies. We also have the most effective modulation across the solar radiation spectrum, which can be adapted to any specific conditions or requirements. We have the lowest manufacturing cost, based on low-cost BOM and a very simple manufacturing process that already exists, specifically developed to be made on existing display manufacturing facilities and can therefore be scaled in volume very quickly. Here we have a short video of our technology switching for an architectural application. For such an application, fast switching capabilities are not required. Just swift, noticeable change as the conditions outside might also change. In order for dynamic glass to be truly useful in the battle against climate change, it must be capable of modulating not only visible light, but also those aspects of solar radiation that impact heat within any given space. As can be seen here, visible light forms only a part of the overall energy from solar radiation. On the other hand, here we see just how effective ELM technology is in modulating energy across this spectrum. This graph represents an early example of our solar control inks, and work is continuing to improve even further on these capabilities. The blue line in the top half of the graph represents the transparent state of ELM technology, whilst the black line towards the bottom of the graph represents the off state for ELM technology. Here we have an example of the versatility of ELM technology. Being based on extremely robust pigment science, we're able to produce inks which can modulate across almost any selected spectrum range, including being able to modulate only in the invisible range, permitting independent control of thermal radiation over visible light, always with the ability to be completely color neutral. The robustness of the technology is important. The applications for these technologies can be very challenging, with warranty requests of more than 10 years. Another sign of the versatility: we can even make this technology on plastic substrates. Essential for many automotive applications where flat surfaces simply don't exist. Our business model is to work with existing manufacturing partners within the display industry, where Elstar develops both the design and supplies the electrophoretic inks, eliminating the need to build new factories whilst targeting established, mature, and highly effective manufacturing processes. Global climate initiative has created unprecedented opportunities for dynamic glass. With the introduction of the Dynamic Glass Act, a part of the Inflation Reduction Act in the US in 2022, and the upcoming European Net Zero Industry Act, we are already seeing federal legislation coming into law that will ultimately mandate the use of such technologies. However, we are already seeing enormous interest from other industries, including automotive. And even consumer electronics, where billions of dollars have been invested in developing high-fidelity transparent display technology. Imagine being able to turn your window into a TV by combining existing display technologies with an effective light modulator. All Elstar demos and prototypes have been produced using 100% existing commercial processes. We use around half the number of manufacturing processes of an existing TFT LCD. The arrays are extremely simple in construction, and the bill of material is also less than 50% of the bill of material of a TFT LCD. So we know we can achieve the lowest cost per meter squared of any dynamic glass technology on the market. The forecasts for dynamic glass by the end of the decade estimate the need for up to 30 million square meters per year. The current forecast capacity for existing technologies is only around 2 million square meters per year. Yet the global capacity within the display industry is in the region of 400 million square meters per year, much of which, as we know, is massively underutilized today. So not only could the display industry make a significant contribution in the battle against climate change and help save the world, but it could also, in the process, help save itself. Dynamic glass market is expected to be in the range of $15 billion to $20 billion by the end of the decade. However, to be competitive, dynamic glass must be effective. It must be affordable, and it must be scalable. Thank you very much for your time today. If you have any questions, please refer them to my colleague on site, Dr. Guo, or feel free to contact me directly by email. Thank you.